Start the recording. Okay, it's recording. Let me open the whiteboard. Share. Yeah. Okay. Black. Okay. So we are going to start off with the derivative of e to the f of x. Basically, today we are going to talk about the derivative of exponential function. And this e to the f of x means, we have seen e to the x, we have seen e to the x squared, we have seen e to the 2x plus 1. All these are functions of x. So when we are talking about something generally, we write it as f of x. Okay, is this clear?
Yes.
Okay, so we are going to talk about this. All right. So initially I'll be doing a proof and then we'll move on to examples. So today we will actually see that why the derivative of e to the x is actually e to the x. That day I just told you orally that it is like this, but this proof is going to tell us that, okay, fine that it is e to the x, but why is it e to the x? Okay. So let y equals e to the u. And obviously, u over here is f of x, very fair. So we will write u equals f of x, fair enough. Okay, now we are going to differentiate y with respect to u. Okay, we will be differentiating this equation at both sides according to u. So this would be dy by du, and this would simply be e to the u. Okay, next step would be we need to differentiate this as well with respect to x. This would be du by dx. I'll be explaining it to you again, don't worry. And what would this be? This would simply be f dash x. Okay, perfect. Next, we need to see that dy by dx is dy by du into du by dx. That is e to the u into f dash x. This is e to the f of x f dash x. Let me write down this y over here. Okay, I'll explain you. So we were trying to see the derivative of y equals e to the f of x. Okay, in short, we were trying to see that what would be the derivative of a function that has exponential, and in the power of exponential, we have a function that has x. Okay, so we supposed that y equals e to the u. Whenever we are proving something, we have to suppose things. Okay, all you need to do is you have to understand this proof. You don't have to memorize it, you need to understand it. Okay, so initially to prove this, we took y equals e to the u, and obviously u is f of x. We can already see that. We are going to differentiate it with respect to u, and we are going to differentiate this with respect to x. Okay, this side would be dy by du, and when we are differentiating e to the u with respect to u, it would be e to the u as it is. Remember?
Yes.
Okay. And this would be du by dx, and this would be f dash x. This dash means at the moment we are not sure what the function is. The function could be x, the function could be x squared, whatever the function is, the derivative of this function would come here. Okay. Now we have these two things, but remember, we need to find the derivative of y with respect to x. Here we have derivative of y with respect to u. Here we have derivative of u with respect to x. But we need derivative of y with respect to x. We needed this. In order to get this, we had to find these two. Okay. So dy by dx would obviously be dy by du into du by dx. Do you understand this?
Yes.
Excellent. So this is e to the u and this is f dash x. We have simply substituted these two values, and this is finally our answer. This is what we have been doing. But initially, I don't know, but at times we're just in practice of doing something and we don't know the underlying logic behind it. This was the logic. Whenever you are given with a function, with an exponential function, which has something in its power and it's a function of x. The power is a function of x. You have to write it down as it is, and the derivative of this power would come here as product. Okay, two things. The exponential function would come as it is, and the derivative of this would come here as it is. Is it clear?
Yes.
Perfect. Okay. So let's just move on. Okay, so here's a key point. Key point is that, let's say y is e to the ax plus b. So dy by dx would be, again, the exponential function would come as it is, and the derivative of power, that is ax plus b. The derivative of this power is going to be a. Okay, so a e to the ax plus b. Why is it a key point? You told me that you had issues with time management. Now, obviously, if you are given with a question like e to the 2x plus 1, you would not be writing down each and everything that e to the f of x and then f dash x. No, you simply have to do it this way. This 2 would come like this, e to the 2x plus 1. So, you can learn. I would not suggest you to learn something, but when you be practicing past papers, but you would naturally be learning a few things. Okay, is this example clear?
Yes.
Okay, let's talk about another example quickly. Okay, so here we have e to the 2x. So this would be very simple. E to the 2x by dx. This is going to be e to the 2x as it is, and 2 would come as a product. So this would be 2 e to the x, right? These examples are very easy. So I hope it is clear. Is it clear?
Yes. It's clear.
Okay. Next example is a bit tricky. I'm sure it won't be for you, but if it is, obviously, this is why I'm here. F of x is x e to the minus 5x. Now, this is a function and you have to differentiate it. Okay. Do you have any idea about what product rule is? No?
No.
Oh, no. Okay. No problem. Okay. So here we can see one thing, that it is not just exponential function, but it has something in product, and that something is not a constant. That something itself is x. Okay. So in this case, we need to use the product rule. 4.3 and 4.4 are, I guess, are product rule and quotient rule, and there we would be discussing in detail. But for this example, I would be giving you an overview. Okay, over there we will be discussing it in detail, but for this example, I will discuss it. Okay, product rule. Let's say you have a function f of x and g of x. Okay, let's say that your question was x square into 2x plus 1. This is what you were asked to differentiate. So can we just say that x square is f of x and 2x plus 1 is g of x, as in these two are two functions of x? Okay.
Okay.
Okay. So one way could be that you simply, multiply it and say 2 into x cube plus x square, and solve it simply, like, 3 into 2 x square, and that way, right? But in this case, you cannot multiply anything. You cannot solve it that way. So you need the product rule over. The product rule says any function could be the first function. Let's say f of x is the first function. First function would come as it is. We will write down the derivative of second function, plus second function would come as it is, and we will write down the derivative of first function. I'll explain it to you again. Okay. Here we have f of x equals, let's say this is, okay, yeah. This was the question, and we were asked to find out the derivative of this whole expression, right? But this whole expression cannot be simplified into something of this sort, and we have never learned how to solve such differentiations. Okay, so for such differentiations where you have exponential and x, it could have been that there was x squared, x cube, or any function that had x in it. You simply need to use the product rule. The product rule says, let's say that x is the first function, e to the minus 5 of x is the second function. Okay, so f of x would come as it is. First function would come as it is. Derivative of this function. What is the derivative of this function, Ranjani?
This will be minus 5 e to the power negative 5x.
Excellent. Okay. Plus, and which function, what am I going to write over here?
G of x will be 1.
Sorry?
Oh, sorry. E to the power negative 5x.
Excellent. And what is going to come here?
1.
Excellent. This is, now you have solved this. Okay. So simply, rule number, we don't get into the details. I will be explaining you the product rule later on. Just know that this is a formula which we use in order to solve differentials where you have two functions of x and which cannot be simplified like this. Why would we use this product rule for this function? I mean, we can, the answer would be correct, but when we can simplify it this way, we don't, feel like using the product rule. But for such functions where things are complicated, we cannot multiply x with the exponential function. Can we? We cannot. So we have to use the product rule. Here the learning was that how are you going to solve the exponential function, as in how would you find its derivative and plug in into the product rule. So I will be repeating it for the last time. You can have any two functions as a product. This function had x and e to the minus 5x. Okay, and yes, you can also solve it this way. You can also say that f of x is e to the minus 5x and g of x is x. Let's see this way. So what would come here? F of x. What is f of x in this case? Sorry,
e to the power negative 5x.
Excellent. And what is g dash x in this case?
1.
Very good. And what is g of x?
G of x is
Yeah, excellent. X. And what is f dash x?
Minus 5 e to the power negative 5.
Very well done. So you can see that these two answers are same. These two answers are same. So this implies that f of x and g of x are any two functions of x. You get you have the freedom to decide which function is f of x and which function is g of x. Okay, there's no hard and fast rule. Okay, you simply all you need to do is plug in the values. Simply you have two functions of x, you have to find the derivative. Okay, take f of x as x, just take it as h in order to avoid confusion. And g of x is e to the minus 5x. Simply find f dash x, that would be 1. Simply find g dash x, which would be minus 5 e to the minus 5x, and plug in the values. Okay, and your answer would be correct. Okay, but don't worry, I would be explaining this product rule in detail when we will go to that section. At the moment, all you had to know is that how to differentiate this exponential function. I hope it is clear now. Okay, perfect. Okay, yeah, okay, product rule is done. Okay, so obviously if you don't know the product rule, you would not be knowing the quotient rule as well, right? Okay, so I will discuss this example. Let's solve a past paper question. This is a very interesting one. So let me write it down. The equation of a curve is y equals e to the 2x minus 9 e to the x plus 7x. Full stop. Find the exact value of x coordinate at each stationary point and determine the nature of stationary points. Okay, so do you have any idea what a stationary point is?
Yes, stationary point is where dy by dx is 0.
Very good. Okay. And when is
It's
dy
like
by dx 0?
when the curve is at a maximum or minimum point.
Excellent. So if this is a curve, let's say this is a stationary point and this is a stationary point.
This
Okay.
is a stationary point.
Very good. This
Yeah.
is maximum point, this is minimum point. Okay. So there, what the question says, the equation of a curve is this. This is a curve with this equation. We have no idea about how the curve would look like because it is an equation in, exponential functions. We don't care about that. Find the exact value of x coordinate at each stationary point. But we know that at stationary points, the derivative is 0. Okay, let's just solve this part and then we'll move to this part. Okay, the exact value of x coordinate at each stationary point. This was the y. So how would we be forming the equation? Okay, equation.
So first, I think you need to find dy by dx of the
Very good. Yeah,
function, right?
excellent. And let's write it down. Dy by dx. Okay, so tell me what would be the derivative of this function?
2e to the power 2x
Very well done.
minus 9e to the power x
Excellent.
plus 7.
Plus 7. Okay. Yeah. And we are saying that,
Then you equate it to 0.
yeah, it equals to 0. And we are asked to find the exact value. So, but how are we going to find the exact value? I mean, would we take this?
You can write e to the power x as u or some value, and
Very
then
good. Excellent.
find the
Excellent.
quotient.
Yeah, very well done. So, yeah, we can either take e to the x as u, or we can simply, we can see that here we need two numbers such that their product is 14 e to the 2x. And if we add subtract them, our answer is minus 9 e to the x. And one thing which we know is e to the x into e to the x would be e to the 2x. Okay, this is what we know. All right, so it is very obvious 2 and 7 are the two numbers. 2 e to the 2x. Okay, so it should be, okay, yeah, minus 2 e to the x minus 7 e to the x plus 7 equals 0. Yup. And 2 e to the x minus 1 minus 7 e to the x minus 1 equals 0. 2 e to the x minus 7 e to the x minus, minus 1. Okay, this is 0. Okay, now 2 e to the x minus 7 is 0, or e to the x minus 1 is 0, and the answer would be 2 e to the x is 7, e to the x is 7 by 2. And you know what would we do, what we'll do after this step? In order to find the exact value of x?
You have to take ln.
Excellent. We'll take natural log on both sides, so this would be resolved.
So e will be
Yeah,
cancelled.
e and natural log will be cancelled. X equals natural log 7 by 2, and the other one would be
0.
very good. X is 0. Okay. Oops. Yeah. Okay. So this is and 0. Okay. So these are the x coordinates of the stationary point, right? The second part says and determine. Oh, okay. What is happening? Just a second. Yeah. Okay. The second part says, and determine the nature of stationary point. Now, what do they mean by the nature?
So I think they mean that whether it's a maximum or a minimum point.
Excellent.
So
And
you
how
have to
do we
take the
determine?
second derivative.
Okay. Okay, and then let's just first the second derivative and then talk about d square y by dx square equals. Okay, so what would be the second derivative in this case? This is going to be
4e to the power 2x
yes,
minus 9e to the power x.
excellent, very good. Just give me a second. Hmm. Just need to confirm something. Okay, yeah. Yes, perfect. Okay. And now you said that, okay, we need the second derivative. And what are we going to do? We need to see if, okay, but what do they mean by nature of tertiary point? That it is either maximum or minimum, right?
Yes.
Okay.
This will be a minimum point.
This is which one would be minimum point? We have 2 points. We have 2x coordinates. 2x coordinates mean we would have 2 y's and hence we'll be having 2 points. So let's talk about x to the 0 first. This is a simple one, okay? So 4e to the 2, 0 minus 9 e to the 0. This is going to be 4 minus 9, that is minus 5. The answer is negative.
Minus 5. Yeah. So this will be a maximum.
Excellent. But why would it be the maximum point? Do you know that? Do you know the reason behind this concept?
No, I just know if it's negative, it's maximum, and if
Okay,
it's positive, it's minimum.
I explain you this concept because this is one of the basic concepts in mathematics and we should know that. Okay. And simply, if I solve it for the other one, 4 e to the 2 ln 7 by 2 minus 9 e to the ln 7 by 2. So how are we going to solve this, Ranjani?
A calculator.
You simply, obviously you can use a calculator, but this 2 would come over here as a power. You know that, right?
Yes.
So this would be cancelled and this is going to be minus 9 into 7 by 2. This is going to be 4 into 49 by 4 minus 63 by 2. 4 and 4 would be cancelled. And the answer would be positive. And this is going to be a minimum point. So we know if our second derivative is negative, the curve is, the stationary point is maxima or maximum. And if the second derivative is positive, the stationary point would be a minimum point. Okay, agreed. But let's see why is it so. I'll just take 5 minutes because it is something which I think you should know. Let's consider a simple example. Okay, let's take this as an example. Okay, this point, this is y, this is x. And here I'm going to plot another graph of dy by dx and x. So you can see that here the derivative is, what is happening to the derivative over here?
It's decreasing.
Yeah, it is decreasing. And what is happening over here?
It's increasing.
Increasing. So what does it mean? That the negative gradient is basically, going to 0 and eventually it is becoming positive, right?
Yes.
Okay, perfect. So this would mean that look, here is the derivative. Okay, derivative is negative and it is becoming positive, and it was 0 at a point. Okay, this is the derivative. Remember that concept I explained you that day when when I made two graphs, one was of the y function and the other one was of the derivative function.
Yes.
Okay. Is it clear? Till
Yes,
now,
it's clear.
I have explained that this is a curve. The derivative is negative. It is becoming 0, and then it is becoming positive or increasing. And this is what this graph tells, right? Derivative is negative. These values are negative dy by dx, and these values are positive dy by dx, and this is 0. Fair enough. And if we talk about d square y dx square, that is the second derivative. I'm not going to plot the graph, but the derivative of this line is clearly positive. We know that, right? It is going upwards. So it has a
Upwards.
positive. It has a positive derivative. And this positive derivative meant this minimum point. Okay. Now,
Yes, I got it.
you got it? Okay, so
Yes.
it basically, the concept behind it was that the derivative is negative. From negative, it is becoming 0, and from 0, it is becoming positive. So this is why we consider positive second derivative as minimum point and negative second derivative as positive, as maximum point. Sorry, yeah. Okay, is it clear now?
It's clear.
Okay. Now I am going to, yeah, we have 30 more minutes. Okay. Well, I have a last example for exponential function. I really wanted to do it. Okay. So the example is, let's say, don't get confused with this h of x, f of x, g of x. Okay. This h of x
Okay.
simply means a function of x. That's it, nothing else. And I'm using h of x over here because of the reason, because we'll be needing g of x and f of x ahead. 3x divided by x squared. Now this is a question, and what if I ask you to derivate it? How would you attempt it, Ranjani? Any idea?
Yes, I would do e to the power 3x times x to the power -2, and I would do
Excellent.
the f of x times
Excellent.
g
Very
of
well.
x.
Very well done. Perfect. Yes, you are 100% correct. Either you can rewrite the question as this and use the product rule, okay? Or you can simply use the quotient rule. The quotient rule. Quotient rule. Yeah. Okay, so the quotient rule says if you are to derivate something that is of the form f of x divided by g of x, you are going to write it as g of x f dash x minus f of x g dash x divided by g of x square. Okay. Okay, Ranjani, in product rule, I told you that any of the two functions, like this could have been f, this could have been g, this could have been g, this could have been f. Okay, fair enough. But if you use the quotient rule for this function, what would be f and what would be g?
Thing.
Sorry?
You can choose e to the power 3x as f of x, or you can choose x to the power -2 as f of x. It can be anything, right?
Okay. It could have been anything if we were talking about the product rule. Here, this is quotient rule. When you're talking about a fraction, you have to be sure that if something is numerator, that is f of x, and if something is in denominator, it is g of x. Okay? Because this way everything would go wrong. This is the basic structure of the question. Here you were asked to differentiate this question, right? In this question, this is the numerator, this is the denominator, and the formula for quotient rule, which you have been told is that you have two functions and it is a fraction. So the denominator would come as it is. The derivative of numerator would come next to this one. Then you have to put a minus sign. Then the numerator would come as it is, and then the derivative of the denominator would come over here. And then you have to divide this whole thing with the square of the denominator function. Okay, so the quotient rule is complicated if you compare it with the product rule, but all you need to know is you have to learn this formula and you're good to go. You have to learn this formula, and once you have learned this formula, now you will tell me how I am going to substitute values using this function and these values. Okay, so first question is, what is f of x?
F of x is e to the power 3x.
Very good. And what is g of x?
G of x is x squared.
Very good. And what else do we need to use in this formula? F dash x and g dash x. Only these two things. So we'll simply
F
calculate.
dash x is 3e to the power 3x.
Very good. And g dash x
G
is
2x.
excellent. So we'll quickly substitute all the values. X squared, 3e to the 3x minus e to the 3x 2x divided by, what are we going to write over here?
Square whole square, like, so it will be x to the power 4.
Very good. So, again, another tip. You are someone who is not that good at time management. This is what you told me, and you do silly mistakes. So you can learn the formula, and you have to learn this formula. Okay, there's no proof for this formula. You have to learn this formula. So you will write down the question. You will write down the formula. Now you have to see, okay, I need this, I need this, I need this, I need this. You will simply see, okay, I have f of x as this, u of x as this, and you have to write down the derivatives and then simply plug in into the formula. Okay, is it clear?
Yes.
Perfect. Okay. Now let's
So
move
are
on.
we supposed to simplify it further?
Yeah,
Because
sure.
it's...
Yeah, yes. We are going to simplify it, definitely. Okay. So this would be, let's take it as common. E to the 3x and x can be taken common. We would be left with x, 3x minus 2 divided by x to the 4. We can cut it. This would be 3x minus 2 divided by x cube. Okay, this is how you have to simplify it. Right?
Yes.
Okay. Is it clear? Are you sure?
Yes, it's clear.
Perfect. Okay, we have 25 more minutes and we have to complete the natural law. Okay, now let's talk about the derivatives of Lnx. Okay, so again, we'll be using the same format. First, we have to discuss that proof where we substituted u and we did that substitution and finally proved. And then we'll discuss some questions as well. Okay, so this is that. Okay. So let's take y equals ln f of x. And this is f of, just a second. The derivative of ln f of x. Again, f of x, why? Because this natural log can have any function of x, okay? We don't know, it could be x squared, it could be x, it could be anything. So y equals ln u. This is our substitution. Obviously, where u is f of x. Simply, the way we did it in case of exponential, what would be the next step?
The next step will be dy by du.
Excellent.
I mean dy by dx.
dy, okay, listen, we need
Yeah.
dy by dx, we need dy by dx, fair enough, but here we have f of x, so we cannot directly say anything about this function. We need to make substitutions, and then eventually we'll be finding out dy by dx by using dy by du and du by dx. This is a trick, okay? We need to find dy by dx, but since this is a general function, for general functions, we can never ever write down the derivative as it is. So we have to make some substitutions, find the values of dy by du by dx, plug them here, and then we have to write down the value of dy by dx. Is that clear?
Yes.
Okay. So this is going to be simply, what do you know how to solve the natural log derivative?
No.
Okay. So basically, in case of natural logs, what we are studying over here, this function would come here as it is, and the derivative of this function would come here, which is 1. Okay. So by the end, you'll see we'll actually be proving this thing.
Derivative of ln is 1.
The derivative of ln u is 1 by u. Why? This function would come in the denominator as it is, and the derivative of this denominator would come over here in the numerator. So the derivative of u is 1, right? The derivative of x is 1, right? So the derivative of u is 1. Is it clear?
Can you please explain how it's 1? I still didn't understand.
Yeah, okay, I'll tell you. Okay, so what if I say y equals x, dy by dx would be, okay, 1. So this is how it is, like this. This is a rule for natural log. Do you understand the rule that this thing would come in the new denominator as it is? We had u came here as it is, and the derivative of this function or this function, which are same, is going to come over here. And this case, the derivative of u is 1, like the derivative of x is 1. Don't look at this ln over here. We are simply putting the derivative of this function. We are differentiating this function with respect to u. You know the way the derivative of x is 1? What if I write, okay, so what if I write y equals u? What would be the derivative in this case?
1.
1. This is what it is.
Oh, okay.
Consider it as a function, and the derivative of this function would come here. And this is what we are basically trying to prove. These proofs are a little complicated, but this is how you prove them. When we prove something, we cannot question the fact that why are we doing it. This is how the proof it. So this is how the proof is. But we'll end up at something, then I'll relate to it. Okay. Okay. So we are done with dy by du. And what are we left with? What is the next thing which we have to prove?
du by dx.
Excellent. Du by dx. So what would this is the derivative of this side, and what is the derivative of this side with respect to x?
F dash of x.
Excellent. Very well done. So dy by dx would be dy by du into du by dx. Dy by du is 1 by u. I'll be explaining this again, don't you worry. Into f dash x, and this u, what was this u? Can you find this u somewhere up there?
Yeah, u was f of x.
Excellent. F dash x. Okay, look. This is what I tried explaining you over here. Whenever you are asked to derivate natural log, and the natural log has a function of x in it, you simply need to all you need to remember is this. You will write down this function as it is in the denominator. Okay. And you have to differentiate this function. It could be x squared, it could be 2x plus 3, it could be anything. We will be discussing some examples. And the derivative would come in the numerator. So this is basically f dash x over f of x. This is what we have done here as well. We had this u in the in place of function. So we wrote it as it is in the numerator and the denominator, and the derivative of this function is 1. So this 1 came here, right?
Yes.
I think it's confusing you. It's still confusing. Is it
No,
confusing?
no, it's fine. It's fine.
Okay, honestly speaking, these proofs are like that. You don't need to learn something, memorize something. Just go with this formula. You need to learn this formula only, okay? And this was just for completeness because I was following a book and that book had this. And these proofs are very common in bachelor. So if you plan on doing BS Math, you will get to see them a lot. But they are not difficult. At times we think like, okay, this is what we had to prove, but why is it here? This is how things work in maths, okay? So the only learning here is this, that's it. That if you are given a natural log with a function and you have been asked to derivate it, you have to do it this way. Okay, let's just quickly look at the examples and then we'll get a better idea. Okay, now we have enough time. Right, so example 1. ln ax plus b. This is just like the key point we did in case of the exponential function. And there it was, e to the ax plus b, and the derivative of that is a into e to the ax plus b. So these key points are just so you can solve questions quickly. Okay. Okay, so we have to derivate it. We don't know how to derivate it. Okay, so we will just write down it like this, and derivative of this with respect to x is nothing but a fraction where the denominator is this function as it is, and the numerator is the derivative of this function. So see, when we are differentiating natural log, the derivative in the derivative we have no natural log. Natural log is gone. All we are left is with the function and its derivative. That's it. And this is how we do it. Okay. Okay. So this is the formula, right? This is the formula which we have learned, but this was the question. So what is f of x in this case?
F of x is ax plus b or
Excellent.
ln of a, yeah.
No. Look,
Okay,
ln
ax plus b.
into f of x. This was the format, right? If we compare these
Yes.
two, ln is same. This is the difference, right? So f of x is the function which we have after ln. This is the difference. Okay. Okay. So obviously we have to differentiate this, and this is the formula. So we have f of x. What else do we need to find?
Dash of x.
Very good. F dash of x is simply a.
1 by ax plus b, or
Yeah, look, in this case it's a. The
okay.
derivative of f of x is a in this case, right?
Yes.
Okay. So the answer would be a over ax plus b. Is it clear?
Okay. We're not supposed to do 1 by ax plus b
Okay.
times.
Wait. In that example, we were talking about u, okay? In that example, f of u was u, okay? Now think of it. The derivative of this would be f dash u divided by f of u. So f of u is u, right? And the derivative of u is 1. So in that question,
Okay, yeah, I got it.
yeah, just think of it like this. Just think of it as if you had x as f of x. So in that case, your answer would be 1 by x. But here we had ax plus b. So the derivative of ax plus b would come here and ax plus b would come here directly. Okay, I'll explain it to you again.
No, I got it.
Are you sure?
Yes.
Because this is what I'm here for. You can ask me honestly. I would not mind that.
Fine, I got it.
Okay. Okay, now let's try solving a good example. Second. Yeah. Okay. Example 2. Ln the root minus x. Okay. So we have to, okay, step number 1. We don't know how to solve it fair enough. We are going to follow each and every step. D by x. So we have been asked to, let's just assume that we have the question derivate the function. Okay, function, and this is the function f of x. No, don't use f of x, use g of x. G of x equals this, and we have a question in exam which says that you have to derivate it. Okay, so we will write down g of x equals basically d by dx ln under root 5 minus x. Okay, so what is the format? What is the format? How do we solve, or how do we derivate natural log questions? The format was simply we write down g of x in the denominator, as in if we had, just a second. Okay, so the format was that this is going to come here as it is and the derivative would be here. Okay, this was the format, and this is the question to be solved. So let's go further. We are not going to solve it directly. We will first, dx natural log 5 minus x 1 by 2. Okay, I've written this 1 by 2 in order to solve this.
Yeah.
So this is f of x. What is f of x in this case?
F of x is 5 minus x to the power 1 by 2.
I hope this h of x, g of x, and f of x is not confusing you.
No, it's fine.
Yeah, because these are just random functions we are using for making this question easier. Okay, you could have written nothing, you could have solved it directly. It's just to make it easy. It's just because this is what we know. Ln for a question of this type, we know that this comes as it is and this comes in the derivative, in the numerator. Yeah, this is the format, and here our h of x is this and h dash of x is, what is h dash of x in this case? Do you know that?
Yes. So you can take 5 minus x as u.
Okay, and
then you can just
yep, I understand. Okay, so I take this as u and then I will multiply the derivative and then I'll, okay,
you will get 1 by 2 u to the power negative 1 by 2.
very good. And what about the
And
derivative of?
then you have to do derivative of this, so it will be negative 1.
Excellent. So
And then you have to substitute 5 minus x in the u.
very good. This, right? This would be our answer. Yeah, perfect.
Yeah.
So now we are done. We had to find this and this. We are already done with these two things. So the answer would be minus 1 by 2, 5 minus x minus 1 by 2 divided by 5 minus x 1 by 2. Now this answer is not simplified yet, okay? In order to simplify it, we can take this in the denominator, right?
Yes, you can.
And what would it become? 1, when it will be taken to the denominator, we would have 5 minus x 1 by 2. 5 minus x 1
So
by
it'll
2.
just be 5
Very
minus
good.
x.
Yeah, perfect.
Yeah.
Perfect. Excellent. Yes. So this is how we are going to solve it. And we had a negative over here. This is the answer. Yes. Okay.
Yes.
So not to worry about, all we know is if we are given with a natural log and it has something of x type, it could be x square, it could be anything, and we have been asked to differentiate it. This is the formula. Take this function in the denominator as it is, find the derivative of this, and write it down in the numerator. This is the rule, okay? So first, we have to write down the basic formula. We have to see what is h of x or what is f of x, whatever you feel like taking. Then we have to see the find the derivative of this function and simply substitute them, and this is the answer, okay? Yeah, we just have 6 more minutes. You have a class at, right? Mm, 9:45. Okay, okay. Last class exam.
I not today.
Not today. Okay. But we should be in practice of binding up things.
Yeah.
What is that? Obviously, I can explain you more if you feel like, if you're free. Okay, you can ask me. 1 hour does not mean it's 1 hour. I mean, it is for you. But if you want to ask me something, you still can. Okay, don't worry about the timings and things like those. Obviously, if you're free, if you have a class, if you have any other commitment, then you have to go. I understand that. 2x divided by x cube. Okay. Now, again, how are you going to attempt this question? And you have been asked to differentiate both sides with respect to x. Okay, this is the question.
You have to use the quotient rule.
Excellent, very good. And how are you going to use the quotient rule? What was the quotient rule, by the way?
Quotient rule was yeah, g of x f dash of x minus f of x g dash of x divided by g of x the whole square.
Excellent. So this function, the denominator would come here, derivative minus. The product rule had plus. This has minus. You can remember this by, this line. So this is fraction minus. This is just something to, remembering tip, because I always mix this minus and plus. F of x, g dash of x divided by gx whole square. Okay, right?
Yes.
Okay. And now step 2 is, okay, step 1 formula. Step 2, what is f of x? And what is g of
f
x?
of x is f of x is 2x.
Just a second. Now tell me.
F of x is 2x.
Look, at the moment, we are not talking about how to differentiate the natural log. We'll come to that, but here we are first resolving functions for the quotient rule. So in the quotient
And
rule,
it will be ln of 2x.
excellent, excellent. Okay. And what is g of x?
G of x will be x cubed.
Very good. Now we have to talk about f dash of x. Now here you will tell me what would be the derivative of this function. Okay, so d by x ln to x, and the formula said okay. So this is what we have already learned, that if you have been asked to find the derivative of a natural log function, derivative of this thing would come here and would be divided by the function as it is. Okay, so again, look, things are like over here. Just consider this. So what would be h of x?
Of x will be um
Look,
yeah,
inside the thing which is inside ln.
will be 2,
2x, okay,
yeah,
2x.
2x.
And h dash of x would be 2. I'll wait, don't worry, it's okay. It's okay if this is confusing you, because this is the first time you have seen the quotient rule, the product rule, how to solve natural log. So I will send you a few practice questions, not too many, just 2 to 3, and you practice them, and then you'll see that okay. Here we were talking about the quotient rule. Now once we were done with f of x, g of x, we had to find the derivative of this function, because this function required this f dash of x. In order to find f dash of x, we had to basically derivate this natural log function. Whenever we are derivating natural log function, this function comes in the denominator, and in the numerator its derivative comes. Okay, so this would be 2 by 2x, and this is going to be 1 by x. Okay,
Okay.
and g dash of x would be 3x square, right? This was g of x, 3x square. Okay, yeah. And next we are simply going to just substitute all the values. Okay, so I will not spend time on that. I would like to explain this again, just so we are clear. Okay, substitution and simplifying is what you have been doing, but this is new. Okay, look, this was the question. This was the question. You were asked to derivate a fraction. Okay, fraction, fair enough. Quotient rule. This is the quotient rule. Quotient rule says you have a function in numerator, you have a function in denominator. The function in denominator would come here as it is, and you have to find the derivative of the numerator, subtract it, numerator, derivative of the denominator, and so on. Okay, so derivative of a fraction, step 1 to write down the quotient rule, and step 2 to find out this g of x, this f dash, this f, and this g dash. And this was very easy. You had this fraction, you had this in front of you, so f of x was ln 2x and g of x was x cubed. And simply step 3 was to find out the derivatives, right? So f dash x, this is what we have discussed today. Derivative of natural log is what? This function, the function in natural log, would come as it is in the denominator, and the derivative of this denominator would come in. So this is 1 by x. And simply we had x cubed as g of x, so g dash of x was 3x square. Okay, and once we have all these values, we simply have to substitute them in the question. Okay, is it clear? I'm sure that you would be confused, badly confused. I know that, just because of this f, g, h everywhere. I know that you are confused. Okay, I'll summarize it quickly. So you were asked to find out the derivative of a function which was in this form. Okay, so we'll simply apply the quotient rule. Quotient rule applied. Fair enough. Now, if you had f dash x and g dash x, okay. Now, if this x itself was a natural log function, so obviously for the derivative of f of x dx, that is the derivative of h of x over x, it is going to be, this is h of x, h dash x divided by hx. Is it okay?
Yes, it's fine.
So don't, I'll send you a few questions from the book I'm using, and do you have a soft copy of your book?
Yeah,
Are you sure you
I
have
do.
it?
Yes.
Okay, so please share that on the group as well, just so I can pick up examples from there. I'm also following an A-level pure maths book, but because at that time I did not knew name of your book. I did not know the name of your book, so I had to, search up for myself. So I'll be sending you. Would you be able to do 2 to 3 questions today,
Yes,
tomorrow?
I
But
will.
before tomorrow's class, just so if you have any confusion, you can discuss that on WhatsApp to save time, and I can prepare the solution, or I can directly WhatsApp it to you. Because
Okay.
you have to practice these questions. The practicing is very important. Okay. So
Okay.
I'll give you four. Yes, I'll give you four, and you can practice more from your book as well. Okay.
Okay.
Perfect. So is everything clear for today?
Yes, it's fine.
Are you 100% sure?
Yeah, it's fine.
Okay, so I'll share 4 questions in an hour or so. You can do them today, you can do them tomorrow, but please do them before tomorrow's class. And
Yeah.
then if you find any difficulties in those questions, we can discuss them on WhatsApp, or in the first 5 to 10 minutes of tomorrow's class. Okay,
Okay.
perfect. Okay, so should I end the this now? Should I end the class?
Yeah. Yeah. Yeah.
Okay, take care. Bye bye.
Yeah. Bye.